Hey guys, Miss Hall here. This week we've been talking about energy and specifically potential and kinetic energy and how those two are related. Remember, potential energy is the energy that is being stored, it's being ready to make something happen. And then kinetic energy is when that energy is in motion, when it's actually doing something. So for example, if we're clapping our hands, when I have my hands out here, here's the potential energy. And then as I move, that's the motion energy. It's kinetic energy in the form of motion. And then when I hit it, that is the sound. So the energy is converted into sound. It also turns into heat because I felt it. And then it's back to potential energy. So energy is always around us and it changes in different forms. It never actually can be destroyed. It just changes form. And so we're going to practice this with an experiment of the spool racer. We saw it in our video at the beginning of the week, and we're going to see it now. So how to make that is to have some sort of spool, which I got a ribbon spool. And as we do this experiment, I want you to think about all the kind of tools you could use. If you want your spool to be a cup like this, see if it would work. Or it could be a coffee can like this. And then try this at home. Do it with your folks, do it with your family members, maybe even have races together. That would be pretty fun. And see what works, what doesn't work. And if something doesn't work, then try it again and see if something else will work. So anyway, along with the spool, you will also need a rubber band. You'll need a stick to kind of help thread it also, thread it through. You will also need to use some sort of toothpick. I just have these kebabs, so this is what I'll be using, okay? You also will need your pen for the wind up, and then the washer as well. And I've practiced this several times. It does not work at all without a washer, so you do need one. You can get one at the lumber store. Okay, so the first step is to thread this through. And if you do carefully, you can do it just with your hands. It would help. And so that's what I'm going to try to do. I have a wide enough hole that if I hold on to this on this side, okay, I might just have to switch hands here. So I'm going to hold it, there we go. Oh, thumb stuck. Thumb stuck. 9. What would be a science experiment without a little humor, right guys? Thumb is out. I'm good. So, got our rubber band in through the spool. So the next thing that we want to do is then have our toothpick on the side. Like I said, I don't have a toothpick. I do have a kebab though. So, what I want to do is then take this stick and tighten it. So it's going to be serving as like a stopper for the rubber band to not be coming through the... Okay, so we're going to do... What I'm doing is actually tighten it around the stick so that it doesn't fall off the stick. And actually, the more that the rubber band is tightened, the more potential energy I'm creating. Because more tension allows for more movement to happen after it's been released. If you think about like pulling a regular rubber band, if I only pull it for just a little bit, you know, it's not going to fly. But if I really pull it back and then let go, it's going to fly. So some of that tension helps create extra potential energy. So that's kind of what I'm doing right here, okay guys? So, it's kind of hard to see. I apologize. Okay. I'm going to kind of push that through. Okay. Alrighty. So, now, the thing is, the stick is way too long that I used. because if it stays like this, then it's going to act as a brake to the movement of the wind up. So I got to shorten it. So that's what I'm going to do right now. Okay, this one's going to be... Okay. There we go. There we go. There we go. Okay. Now we just gotta move this. Ow! I'm good. I'm good. I'll fix that later. Anyway, so, again, why you want a little help. Ow, that hurt. Yeah, I'll figure it out. Alright, so now we got our little toothpick. Now we gotta put our washer in on the other side. So, very delicately. You can see that. Okay, see that, guys? So I'm trying to push it through that. Now, let's see if I can. Hold up. So what I'm trying to do is using this to thread it, actually. There we go. Hey, we got it, I think. There we go. Alright. And just like the other side, I'm going to tighten it just a little bit to make sure it stays on. Okay. So. Alrighty. I wonder if that will be enough. Alright, I think that's pretty tight, actually. Yeah. So, here comes the fun part. I'm going to wind it up, and then we're going to try to let it go. I'm going to, by the way, flip the camera over, so that way you can see it more on the ground level, okay? So, there we go. Okay. So what I want to do is just wind this up. So I'm trying to wind this up as much as I can because, again, the more I wind it up, the more potential energy I'm creating. And then that will let go more kinetic energy when I finally release it. Okay? Okay, you guys ready? Okay, hopefully this works, alright? Trying to get out of the way a little bit. Okay. What? No, don't do this. Huh, I wonder if it's not tied up. Oh, I see what happened. So, one thing I just noticed is if your pencil is past the line, it acts like a break too. So you want to make sure it's really long on one side and then comes a little close in, more like that, okay? Which I think that's the reason why we have the washer there, so it kind of helps stabilize, okay? So I've wound it up. You guys ready? Okay, trying to get... Dang, not very fast, but it did go. So, what would you guys do to make this a little more successful? Would you wind it up more? Would you use a different kind of rubber band? Would you use a pencil maybe? And do it with your family. Get a race going. See who can be the fastest. It might be pretty fun. So go ahead and try it. Talk it over in class what materials you would use and how you would make this better. Alright? And see ya. By the way, if I do this correctly. Anyway, see you guys.